Hey guys, welcome back in. Mr. Marone here with our final lesson of Chapter 6 or Unit 6, whatever you'd like to call it. And we're going to look at conditions of special parallelograms. So this is very similar to when we reversed the thought process with parallelograms. Before we were told it's a parallelogram, or it's a rhombus, or it's a rectangle. Now we have to figure out whether or not we have one of those things. We're going to be given a quadrilateral and look for specific conditions to hit here. So if we look closely at our notes, we said that the diagonals were perpendicular in rhombuses, and we said the diagonals also bisected the angles. So if we're given perpendicular lines inside of our figure, we can identify this as a rhombus. Same thing of our diagonals bisecting angles. If I end up with diagonals bisecting angles, it tells me it's a rhombus. With a rectangle, our defining qualities were that the figure had 4 right angles and that also the diagonals were congruent. So when we're given a figure and they're asking us to name the most specific way to call it, whether it's a rectangle, rhombus, or a square, those are the types of things we're looking for. And then a square has to have all of it. It's got to have 4 congruent sides, it's got to have 4 right angles, it's got to have right angles where the diagonals intersect, the diagonals have to be congruent, it's got to have everything. So basically, to give you a little diagram, here is all of our parallelograms. Inside of that, you have all the different rhombuses, and you have all the different rectangles. And this little part in the middle is where the squares go. So that's where we can start out. When they give us a figure, first we have to verify it's a parallelogram. Then we can try to verify whether it's more specifically a rhombus, a rectangle, or a square. So in these first couple examples, they want to know which one is it. They've told us it's a parallelogram. They want to know if we can be more specific. So in this first one, I've got a diagonal, and it appears that it's bisecting these 2 angles. It looks an awful lot like this guy right here. So that tells me I've got a rhombus. In my second figure here, they've given me the diagonals appear to all be the same measure, and I've got a right angle in the middle. So the right angle in the middle tells me it's a rhombus, and the diagonals being the same measure tells me it's a rectangle. And if I have a rectangle and a rhombus put together, that tells me I have a square. All right, let's try 2 more of these, verifying whether we have a rectangle, rhombus, or a square. So in this first one, they tell us they want to know for what value of x. There's that converse type question again. Makes this a rhombus. So in order for us to have a rhombus, the angles have to be the same measure. The diagonal would have had to bisect those angles. So this angle and this angle would have to match. So in order to do that, we're going to set 6x minus 2 equal to 4x plus 8, and then we're going to solve. And so in this case, the value of x equals 5 gives us a rhombus here. All right, let's take a look at this last one here. So this is a bit of a tricky one. It's going to bring back some algebra, but that's okay. I know it's a little weird, but we're going to be all right. So in this, they gave us that UT right here and ST were our 2 pieces. If this is a rectangle, those 2 pieces have to be the same measure. So we're going to be able to say that n squared equals -3 plus 4n. In order for us to do this, we're going to have to do some factoring. So I'm going to move my 3 across, and I'm going to move my 4n across the equal sign. So I'm going to have n squared minus 4n plus 3 equals 0. And if you need a reminder on factoring, you need 2 things that multiply to 3 and add to -4. And that's the values of -3 and -1. And if you remember how to solve this with that 0 product property, we're going to have n minus 3 equals 0 and n minus 1 equals 0. So n equals 3 and 1. So those are both possible values to satisfy this equation. In order for us to verify, let's just plug back in. So I would have 1 squared, which is 1, and -3 plus 4 times 1, or 4, would also be 1, so that works. And 3 squared is 9, And 4 times 3 is 12, minus 3 is also 9. So both of those do work and satisfy our equation. So I know that last one was a little bit tricky. Try a couple of the problems. Bring in any questions you might have into class tomorrow, and we will talk about them then. Have a great day, guys. Bye-bye.